Just a disclosure, so I do have an IP that we apply for regarding this assay and its applications. I didn't take the time like Dr. Wahlberg and trim through all these intros, so I'll try to go by quickly because if you haven't heard enough about TXA today already, it is a lysine analog and it inhibits fibrinolysis by downregulating plasmin generation by TPA. And it is a very essential and molecule of interest, as we heard today. But what I've learned over the last little while working on this assay is that we need to measure TXA, but why do we need to measure TXA? It has a great safety profile, so I feel like that there's a bit of a give there, and people are willing to use them more frequently and more liberally and generously. But there are reports of seizures, as we discussed today. Sorry, this is kind of a redundant thing, because now that we've all talked about it for the day. But the doses can vary. So this is the one thing that I've realized talking to different clinicians, different surgery performing people, like in front of me here. And it could vary up to 50-fold, and that's not limited to different sites, different institutions. This could be within one hospital, just different people doing, and it's just up for grabs, and whatever's been working for you, you just kind of do it and hope for the best. So I kind of put this picture up there because I feel like it's the wild, wild west, and you can just pretty much do anything as long as you don't kill the person. Possible association with the increased thromboembolic events. And I got to say, I put that maybe there today. I changed the wording to be a little softer because I heard Mackey's talk about how there isn't an association, but then I'm convinced now maybe the other way. So I say maybe, but possibly. And there are no set guidelines for TXA use in invasive surgeries, even for the same procedure. So this is the thing that really struck out to me. And there are no children-specific use guidelines, and that's as a neurodevelopment stages, it could have a profound effect, and we just don't know what that is. I think it's important to understand that. And part of this is because there are no assays in clinical settings that can be translated. Yeah, sure, there are HPLC, mass spec, other ways to measure them, but it takes a lot of time and energy and specialized equipment and technical support to get this done. And so this is where we decided to try and come up with a way to do so. And I'll sort of share my version of fibrinolysis with you and how we envision it in our lab. And this is where sort of the basis of the assay comes from. So plasmin degrades fibrin to fibrin degradation product, or in this case, we call it plasmin-modified fibrin. So it's the early stages of fibrin breakdown where you start generating these C-terminal lysines, and that's represented by the red swoopies there. This process is enhanced, plasmin is generated by TPA, activating plasminogen, but this process is enhanced by about 1,000-fold by the presence of fibrin. This is even further enhanced when you start generating those C-terminal lysines, and this is where TAFE kind of comes into play to knock down those C-terminal lysines, and it reduces the cofactor activity of fibrin. So this is the axis that we focus on to really try and develop this assay. And this is how TXA would function by downregulating both the cofactor activity and thus plasmin generation, as well as likely plasmin activity as well, because then it would inhibit binding of plasmin to fibrin. So there are two components to this assay, and I think this is the key thing here. There are two parts to this assay, and it's very simplistic. First one is simply looking at plasminogen. This is an old existing plasminogen from way back when, I think it's the 80s. It's a site-directed mutagenesis variant. It's got the active site serine mutated to cysteine, which would then, we use a free thiol to attach a fluorescent probe of our choice. We went with fluorescein because it's the cheapest, and then we just had it. Fibrin degradation products are also generated in-house. We start with purified fibrinogen, and then we re-purify to be 13-free. And we cleanse that using ammonium sulfate precipitation, and we label that with QSY, which is a fluorescence quencher. So the idea here is that when QSY labeled FDP, which is the quenching the signal, comes in contact with a fluorescent plasminogen, it diminishes the fluorescence signal from the plasminogen. Presence of TXA will dissociate the plasminogen away from FDPs and thus rescuing the fluorescence signal. So what does that look like in real time? And this is just something I drew up, so this is a real time but not real. You add in TXA and you start getting increase of fluorescence signal back. And the key thing about this assay really is that you get the full reaction within a minute, under a minute. So it's almost instantaneous. We let it run for about 10 minutes just to be sure that we have come to the end of the reaction, and every time it's pretty much instantaneous. So what do? We generate a standard curve with known amounts of TXA spiked back into normal human plasma, and this is the typical standard curve that we generate. And as we heard today, the therapeutic effect, or you need about 10 mg per liter in circulation to have the antifibrinolytic effect. And just for yucks, I just did a quick calculation today. Based on those numbers, assuming there's about 2 micromolar plasminogen and that the reported KD value of TXA for plasminogen is about 1.1 micromolar, this limits to about 98% of circulating plasminogen being bound to TXA at this concentration. And what I didn't show is I also did another run for fun, is to half the dose of TXA, because I think there were talks about 50 versus 100. So what happens if you have 5 mg per liter of TXA? That leads to about 96% of plasminogen being fully bound to TXA, just for what it's worth. Our assay has a very low sensitivity, and its sensitivity is comparable to those that are reported by mass spec. And that works in our favor because we can just simply dilute the samples down, and that also means we need less sample volume to analyze. So we determined the intra and inter-assay variability of this assay, and it turned to be 5.7% intra and 3% inter-assay variability with a limit of detection at 0.28 micromolar. I really should have converted that to mg per liter. I apologize in advance. And then first thing, before we got our hands on any of the clinical samples, we decided to make our own unknown samples, and simply spiking in 2 concentrations of TXA into normal human plasma. And we froze them down, aliquoted, froze them down, and we thawed them out and measured them across a number of days just to see if we can get back what we expect to see. And we do, in fact, get pretty good preservation, and expectation versus measured has good correlation. Of course, that's never going to be good enough to publish. You're going to have to show some kind of clinical samples to validate, or at least give them an idea that this is real. So we reached out to UHN, University of Toronto, Karkouti, and Dr. Gross, Dr. Kevan Karkouti. And we got a number of samples from which, for the purposes of this publication, we had measured 5 patient samples. There are actually 3 time points, but we picked 2 just for the demonstration purposes, the pre and the post of TXA administration. And then we measured them at 2 dilutions, 1 in 5 and 1 in 25, because we had no idea what we were going to end up seeing. And from one of the wise reviewers, we decided to measure, we were told to measure D-dimers in these samples as well, so we went and did that. So these are the D-dimers. Interestingly, they were higher in the pre than they were in the post, but I think the bottom line is they are elevated, and they're there, and that they're measurable in both time points. When we look at TXA using our assay, you can see that this is certainly seemingly sensitive to TXA specifically, and it doesn't appear to be impacted too much by high levels of D-dimer, and those would be clinically high levels of D-dimer. To further appease the reviewer, we were told to look at the D-dimers and how increasing D-dimers could potentially impact our signal. So what we did was we lysed the clots at different times and based on turbidity changes, and we quantified how much D-dimers present in those samples relative to total soluble proteins there were. And when we added those back in to look at our assay signal changes, those extremely high levels of D-dimers did not seem to impact our assay. So even much higher than what's clinically observed in our samples did not seem to impact our signal. So the summary of this assay here is to say that we have an assay that works. It seems pretty darn good for the time being anyway, and it seems to be quite specific for TXA, and it's not impacted by endogenous levels of D-dimer or even supra levels of D-dimer. So what's next then? So we did get a bunch of other samples that were not used at the time the paper was published. So we further analyzed the rest of the samples, including the third time point, and I'll show you that in a second. And our plan also is to measure other fibrinolytic properties with these samples as well to make sure that the data corroborates and TXA is there to shut down fibrinolysis. We also have further studies ongoing with Sick Kids Hospital and U of T, looking at pediatric patients from cardiac pulmonary bypass surgeries. So we'll get on those soon. So this is hot off the press, unpublished data. So we've got the 3 time points, and they're described there before the surgery. The second time point is the post-surgery after heparin reversal with protamine sulfate. And the third one is at the time of the chest closure or 60 minutes after heparin reversal. And again, what I don't have is the data, that the dosage and the timing of TXA administration in the samples, but they do exist. And these are brand spanking new, so it didn't have the time to really go through the comparison and look at the association of how the levels impact the clinical outcomes. So we'll be doing that in a minute. What else is there? Other instances. So what we want to get into, and you know, I'm looking forward to you guys to quash my dreams, because my hopes are high in that I feel like there's so many applications that we can utilize this assay for in cases of a lot of these excessive pathologic blood loss scenarios. And you know, just even from a primary care perspective all the way to vascular trauma, I feel like there is a need and want, at least in my biased opinion anyway. And of course, the next thing we're going to be looking at is the children dosing, and that's in collaboration with Dr. June Teria down at Texas Children's Hospital. And we're going to be looking at TXA use in pediatrics and neonates, and we have a grant that we applied to the ISTHSSC small grant for that particular study. So hopefully, here's some good news soon. And what I was actually quite surprised about is that EACA or Amicar is still being used in pediatric population. I did not know that, and the reason for that is because it's not as potent in terms of antifibrinolytic effect. So they use that in trying to alleviate seizures and other complications that you would see with high levels of TXA. So what can we do about that? Like, are we going to try? I mean, our assay is a lysine analog detecting assay. So based on everything I know, our assay should be able to measure EACA as well as TXA. So we tried out the EACA standard curve, and sure enough, we can measure with decent amounts, a decent sensitivity. It's not as low as TXA, but you would need more EACA than TXA per per molecule anyway. So I think this is a very good promising start. We've only done this twice, so this is also very fresh, and you don't see any error bars on there because we've only done it twice. So other studies, we want to look at the functional validation, as I mentioned. And one of the things also we're looking to do is turning this into a point-of-care testing purposes. If we're going to use this and sell it as a clinically possible option and do routine monitoring, you need a way to get it to people that do the surgery. So we're collaborating with Dr. Gross in his point-of-care device in which they're using a whole blood thrombin generation assay, but we can use the same device, same idea to really test, and we're testing that out right now, and the initial results are somewhat promising, not as good as these guys are, but you're also looking at seconds to minutes in trying to get this to go in one single shot. So yeah, it's work in progress, and hopefully you guys are interested or tell me where we can go with this. I just want to say thanks to everybody, the ones with the asterisks. They were the ones doing all the work, really, and I'm just here. This is a talking piece. And the funding we couldn't do without, and collaborators. And before I go, I just want to, thanks, Tetsu, for advertising the ISFP earlier, because I didn't want to do both, because that seems a bit extreme, but I will advertise here the upcoming Ventura Plasminogen Activation Gordon Conference in 2026 in Ventura. So I would like to welcome you. Thanks.